Of course, we want to know if our correlation is statistically significant or not. A correlation or a regression can be statistically tested in different ways. In many computer software, you will see that the underlying statistical test is an analysis of variance. Here, however, we will use a t-test to test the correlation. We will use the same dataset that we used for correlation and regression of morning temperature and ice cream sales. You might remember in the correlation video, we calculated an R value of 0.96 and an R squared value of 0.92, and we have a sample size of 5. We have measured 5 days. To get a test statistic, a t-value, we use the following equation. We can fill in our R value, and our R squared value, and the sample size, and that will give us a t-value of 5.94. The degrees of freedom in a correlation is n minus 2. Our sample size is 5, which means that we will have 3 degrees of freedom. As usual, we check in a t-table what p-value a t-value of 5.94 corresponds to for 3 degrees of freedom. We see that a t-value of 5.94 falls somewhere between a p-value of 0.01 and 0.005. That means that we can reject our null hypothesis of no correlation and accept our alternative hypothesis that there is a statistically significant correlation between morning temperature and ice cream sales.